Hey everyone, and welcome to this Forge College Explainer. So up until now in your smart contract journey, you've been coding locally. You've been testing everything out on a local Hardhat node, which, is essentially the developer equivalent of reading your lines into a bathroom mirror. It's safe, it's completely private, but it's not exactly the real thing. Well, today we're heading off Broadway. We are going to take all of your hard work and walk through your deployment rehearsal and your testnet interaction. We're taking your capstone project straight out of that cozy local environment and putting it right onto a public stage.
Okay, let's dive right into this. Here is our playbill for taking a smart contract live today. We'll start with the dress rehearsal, move into setup and config, tackle the actual testnet deployment, run our interaction scripts, and finally, we'll wrap up by gathering evidence and performing our final verification check.
All right, let's transition right into our first act. Welcome to the dress rehearsal. So, the main goal we have today is to validate your deployment scripts and your user interactions under totally realistic conditions. You've already written your core greeter contract, you've got your access control layer locked in, and your test suite, it's passing locally. But here's the thing, local tests just do not account for network latency or real block confirmations or public RPC endpoints. So I gotta ask, are you feeling ready for opening night? Look, it is completely normal to have a little bit of stage fright right about now. Hitting deploy on a public network for the very first time can feel incredibly daunting. But I want to reassure you, a flub line here is absolutely not going to end the show. If your transaction reverts, or say you misconfigure a variable, nobody loses any real money. We simply debug, reset, and run the scene again.
As you probably know, testnets are our ultimate safety net. We don't need to worry about real capital. But the network mechanics, I'm talking about the cryptography, the gas limits, the block mining times, and the asynchronous nature of the blockchain. Those are 100% real. It's like a parallel universe. It is the absolutely perfect, risk-free dress rehearsal environment for Web3 developers to prove that their automation holds up in the wild.
Moving right along to our pre-show setup and config. Before the curtain can rise, we've got to prep our backstage environment. You can't just throw code at a testnet and hope for the best. You need to tell your tooling exactly how to communicate with it. Whether you choose to target the Goerli network or Sepolia, you are going to need two specific things. First, an RPC provider. Think of services like Alchemy or Infura. This acts as your direct telephone line to the blockchain. Second, you need a faucet. Now, a faucet is basically a service that drips a small amount of testnet ETH directly into your wallet. You need this so you have the fake gas money required to actually pay for your deployment transactions. Let's quickly walk through the 3 vital backstage setup steps to get this whole thing working. Step 1, you need to verify your local artifacts. Just make sure your contracts are compiled and sitting right there in your artifacts folder, because we are reusing your exact local build. Step 2, we configure our .env file. This file is going to hold your testnet RPC URL, your deployer private key, and a chain name. And step 3, you take the public address of that private key, plug it into a faucet, fund the account, and verify your balance. We are taking the exact Hardhat setup you already know and love and just tweaking the environment variables to point at a brand new stage.
Okay, I really need to pause here for a second and deliver this next point with absolute theatrical gravity. Do not commit private keys to GitHub. Seriously, do not push your .env file to GitHub. Hardcoding a private key into version control, yes, even a testnet key, is the developer equivalent of walking onto the stage without pants. Actually, scratch that, it's a massive security vulnerability. Bots are literally out there scraping GitHub 24/7 for exposed keys. Always use environment variables and ensure your .env file is strictly listed in your git ignore.
All right, pants are on, wallets are funded, let's get to the testnet deployment. Now our environment is secure and our costumes are on. Let's actually transition from the dressing room to the live stage. When you compare your local command to your testnet command, what's really fascinating is, well, how little changes. You are executing the exact same deploy.js script. You aren't rewriting your deployment logic at all. The only thing changing between a local dry run and your live testnet deployment is that tiny network flag at the very end. By simple swapping --network Hardhat to --network Sepolia, Hardhat automatically looks at your config file, grabs your RPC URL and your private key, and broadcasts your contract to the world. It's a real game changer.
Once you hit enter on that testnet command, there is a crucial, absolutely immediate step you have to take. Save the printed 0x transaction hash. As soon as your terminal spits out that hash, copy it. Paste it into a scratchpad, a text document, wherever.
On a live network, transactions actually take time to mine. That hash, that's your tracking number. It's your receipt. It is your first crucial piece of evidence that your deployment has actually been submitted to the mempool.
Deployment is submitted. Next up, running the interaction script.
Seeing your contract deployed is an amazing feeling, for sure. But deploying the contract was really just the opening monologue. Now the actors actually need to interact. We have to prove that not only is the code out there, but it behaves exactly as we designed it to. To do this, you're going to run an interaction script that executes your documented flows. Using a library like ethers.js, your script will connect to your newly deployed contract address. You'll want the script to initialize your registry. It should call public read functions, like greet, just to ensure the initial state is correct. Then, it needs to send actual state-changing transactions, things that emit role change events or simulate a user-level call. You are basically having your script run through the core mechanics of your application on the live testnet to make sure every single gear turns smoothly.
The curtain falls, the show's over. Now it's time for gathering your evidence.
The performance is done and the state is updated. Now we move to the post-show reviews. It is not enough to just say you deployed it. For your capstone submission, you need to prove your performance actually happened. You will need to create an evidence/testnet folder right in your repository, and this is exactly what reviewers will be grading. You've got to collect the deployment transaction hash and the block number it was mined in. You need to save the raw receipt JSONs for both the deployment and all those interactions we just discussed. You'll want to capture the emitted event logs, and finally, construct the block explorer links, like a direct Etherscan URL, so anyone can just click and verify your work instantly. This folder becomes the undeniable audit trail of your success.
Almost at the finish line. Let's do the final verification check. Before you package the whole shebang up for submission, there is one last phase. This ensures the evidence you just collected actually proves a successful, fully functional performance. So, the crucial point here is making sure these 4 checkboxes are ticked. First, code exists. You can use ethers.provider.getCode on your address. If it returns 0x, your contract isn't there. We need to see actual compiled bytecode. Second, events match. The arguments decoded from your transaction logs must perfectly match your expected state changes. Third, state verified. When you make those read-only calls, they have to return the exact expected values. No surprises here. And fourth, reproducible. All your JSONs, links, and text files must be saved securely in that evidence folder. If you can verify these 4 things, your capstone is absolutely rock solid. Which leaves us with one final, incredibly exciting question. Are you ready for the final capstone assembly? Think about it. You've prepped the environment, you've deployed to a live test network, you've interacted with your smart contracts, and you've meticulously gathered your cryptographic evidence. You've done incredible work here today. But ask yourself this. Now that you've seen just how easily your code transitions from a local Mira to a global stage, are you fully prepared for the immutability of mainnet, where a single line of code can literally control millions? To take those next steps in your Web3 journey and officially cross the finish line with your submission, head on over to forge.college. Keep coding, keep testing, and I will see you in the next one.